Going on, guys, let's do this problem right here. It's asking if 2700 centimeters square of material is available to make a box with a square base and an open top, find the largest possible volume of the box. So let's see what we can do. So first of all, I would like to draw a diagram for this one. So let's say this is the box. So this is the box, and they are saying it's a square base box. Square base box means if the let's say if the width is L, the length is going to be the L2, and the height is going to be H. In this case, so since it's related with the volume, we have to know the volume equation. Equation for this box is going to be L square H, because volume is going to be width time length time height, right? So this is going to be the volume. And in this case, if you look at the variables, we have two different variables. So to solve this one, I have to bring everything into one variable. So in order to do that, what I can do is I can take the equation of the area. In this case, they have given the area of this box. This is 2700 centimeters square. Therefore, let's see how we can connect with this L and H. So if I take the area, so the area is going to be in the bottom. We have a square base, so it's going to be area of the bottom is going to be L square. But in the top, we don't have anything. They are saying this is an open top box, therefore we shouldn't add this one, but we have four sides here, four sides of the box. So one side, the area of the one side is going to be length times the height, so it's going to be LH. So since we have four sides similar to the same length and height, we can say it's 4LH. And from this one we know the area is 2700 equal to L square plus 4LH. Now I can solve this one into, I can bring this equation in terms of H. So it's gonna be, H is gonna be, so first of all 4LH is gonna be 2700 minus L square, and if we divide this one by 4L, that's gonna be my H. So since we have the H right here, we can substitute this one into the first volume equation to find the volume. So V is going to be equal to L square times 2700 minus L square over 4L. So if I multiply this one by this, I can get rid of this square, because since we have this L and this L, it cancels each other. Then if you multiply this one by this, I will get 2700 L minus L cube over 4L, 4. Then what I can do is I have to find the derivative, because in this case they are asking for find the largest possible volume of the box. So to find the this one, I have to find the largest length. So in this case, what I have to do is I have to find the derivative to find the absolute minimum and the absolute maximum. So in this case, we need absolute maximum. But before we do that, we have to make sure. So to find whatever it is, we have to find the critical points. So to find the critical points, I have to find the derivative and equalize it to 0. So if I find the derivative of this one, this is going to be 2700 minus 3L square over 4. So this is my derivative of P prime, and in this case I had to equalize this one to 0, to find the critical number. So if I equalize this one to 0, 2700 minus 3L square, and if I equalize this one to 0, I will the bottom will be cancelled, because if you multiply 4 by 0, it's going to become 0, right? So we don't have to be worried about the bottom right now, and we can rearrange this equation to find the L. So it's going to be 3L square is going to be equal to 2700, and if I divide this one by 3, it's going to give me 900, right? 900. And if I find the square root of this one, is going to be plus or minus 30. So that's my L value. First of all, before I go further, what I have to do is I have to make sure these two values are existing, because the length can't be a negative number, so we have to set a domain right here. So we have to set a domain that for L we have to set a domain. So if the L we know is definitely greater than or equal to 0, but in this case it can't be equal to 0, because according to this equation, if the L is equal to 0, then we don't have anything volume or anything else. So it's definitely greater than 0. So L is going to be greater than 0, that's my domain. So therefore the value is going to be just plus 30, right? L is plus 30, and that's my value for L. And now we have to make sure this is absolute minimum or absolute maximum. So to find that, what we can do is we can find the second derivative of this equation to make sure whether it is absolute maximum or absolute minimum. So in this case, what I can do is, so V double prime is going to be equal to 2700 minus 6, like 2700 going to become 0, so we don't have to worry about that. That's going to become 0. So let's take this. So it's 2700 over 4 minus 3L square over 4. So this is going to become 0 right here. And the other one is going to become minus 6L over 4. In this case, if you apply L, any number for L, like L is positive, right? As we mentioned already, if you apply positive L right here, it's going to be a negative number. Therefore, the graph is opening down. The graph is opening down, which means the value we are going to find is going to be the absolute maximum. Therefore, it fulfills the question, because the question is asking find the largest possible volume of the box. Therefore, when L is equal to 30, that's going to give the largest volume. So if you want to find the largest volume, you just plug the values of the L right here in this equation. For example, this is 2700 times 30 minus 30 cube over 4. That's going to give you the volume. And that's how we approach this question. I hope you guys liked this video. See you next time.